The table shows values of variables v and p, which have been measured from an experiment, presumably. By plotting a suitable straight line graph, show that v and p are related by the equation p equals kv to the n, where k and n are constants to be found. Okay, so if we have p equals kv to the n, taking logs of both sides, log p is going to be log kv to the n. So that would give us log p is equal to log k plus log v to the n, and therefore log p is log k plus n log v. So looking at this, it seems that what we need to do is plot a graph of log p against log v, and then log k would be the intercept and n would be the gradient. So the first thing we need is a table with values. So for x it's going to be log v, and for y it's going to be log p. So we'll bring in the calculator to do those values. Okay, well there's a couple of ones that are really straightforward. So for the v, log to the base 10 of 10 is 1. And log to the base 10 of 100 is 2. So those are straightforward to start with. And then we want log of 50. So we'll put that down as 1.7. And then we want log of 200. So log 200. And that's going to be 2.3. So we need log p values now. So we'll start with log of 95. So let's just call that 2. And log of 8.5. So let's call that 0.9. And log of 3. Let's call that 0.5. It's probably a good idea to write these down to 2 decimal places, but you certainly can't plot them that accurately. And then we'll go for log of 1.1. Let's call that 0.04 rather than just 0. We'll try and make the point look a little bit above 0. Okay, so what we need to do is actually produce a graph on this graph paper showing those values. Okay, so log v is my x. Let's put that this way. Probably should have used a different color to that. And then so we know that the other one, log p, is going to be up that way. So this one out here is log v, and up here we have log p. And let's make this 1, 2, and 3, and all those values will then fit along there. And we need to go up to 2 here. Let's just go 1, 2, 3. So 1, 2 is a point. 1.7, 0.9. So 1.7 is around here, and 1.9 would be around there. Then we've got 2. Oh, that's 1.9, 0.9. 1.7, 0.9 is there. 2 and 0.5, that will be there. And 2.3 and just above 0, sort of about there. And then get your ruler and draw a straight line, or as straight as you can, goes somewhere near those points. I haven't done that well. It's not easy to do on the computer screen. Actually, I think I'll probably have another go at that. So let's just get rid of the line I just drew and try again. Easy for you because you should do these in pencil. I've got a bit of a problem up here straight away in that the intercept is off the top of my graph, so maybe I could redraw the scales, but I can work out what the intercept is. It's not a big issue. So let's think about gradient to start with. So we know that that's 2.3 across there, and that seems to be 2. So the gradient is negative as well, isn't it? Because it goes downwards. So it's negative 2 over 2.3. Now the gradient is just the n, isn't it? So that's n. So n is going to be, let's bring the calculator back in. So 2 divided by 2.3. So let's call that 0.87. So negative 0.87. And okay, the intercept, well, that was actually off the screen, so we've got a little bit of a problem, but we can deal with it. So this was 0.5 to there, and that looks like 0.6, so about 0.7. So if we go another 0.5 this way, we'll go up another 0.7. So that would put the intercept at about 3.4. Now, the intercept is log k. So what have we got? We've got log, which remember is log to the base 10 of k. That's equal to 3.4. Well, that means that k is equal to 10 to the power 3.4. So once again, we just need to calculate that. So 10 to the power 3.4. So 2,512, we'll call that. And so we have P is equal to 2,512, that's our K, multiplied by V to the negative 0.87. Okay, I just spotted a mistake here. Okay, well, I spotted that before I moved on to the next bit. So yes, that was 2, but this distance is only 1.3, not 2.3. So my n is actually 2 divided by 1.3, and that's let's call it 1.54. So 1.54, negative obviously, and then so that's negative 1.54 up there. Okay, that's all good. Don't think I made any other mistakes, so that's great. It's always a good idea to check your working all the way in case you make those sorts of mistakes. So the value of n we found was negative 1.54. That's all good. And we know that V is 2,512 multiplied by, sorry, it's P equals, isn't it? P equals 2512 times V to the negative 1.54. Okie dokie. So we want P when V is 35, so it's just substitution. 2512 multiplied by 35 to the negative 1.54. So we just need to calculate that. And what have we got? So 2512 multiplied by 35 to the power negative 1.54. That gives me 10.5, so let's call that 10.5. Let's see if it makes sense. So 35 is in this gap here, and 10.5 is in this gap here. So it does make some sense, at least it's in the right place. Now remember, for this type of question, everybody's going to get slightly different answers because you're relying on the exact line that you drew in the previous part. So as long as it's within a certain limit, you'll get the marks.